Welcome sa to ang next sample problem for design for flexure and shear sa to mechanics of deformable bodies. So this is our sample problem number 3. So find the cross-sectional dimensions of the smallest square beam that can be loaded as shown. So in the previous sample, ato ang gipangita is ang maximum load nga pwede nato ipa-carry kang beam. Karon ato na pong ginapangita is ang dimension ni beam and then smallest square beam. So sa ato pa, we need to find the dimension, the smallest possible dimension ni beam nga square. So if this is the base, then let's say this is the depth or the age. Since this is a square man, pasabot, the depth and or the height is equal also to the base. So natay given diri nga beam, so imong kahadlok ani no, this one. Actually, this is a internal couple. So kung inyo nang i-drawing, ang other way pagka-drawing ana, actually inyo naman ang permi makita, murara na siya kingani nga beam. We have a reaction 1 on the left, reaction 2 on the right. Tapos we have 5 kilonewton load dire. Tapos ang dire is murara na siya og kuan ana ay moment 2 kilonewton meter. This one mo nang M. Ana ay mong ka-shock. So smallest beam and then ato ang kuan din, so natay condition. Dapat ang shearing stress is less than 1 megapascal or equal to 1 megapascal. And then ang ato ang flexural is 8 megapascal. So smallest square beam. Okay. Usually basta ingani, diba, if we have a beam, so mangita mangyutag kuan, diba, for shear stress, maximum shear stress, we have 3V over 2BD. And then for the maximum bending is we have 6M over BD squared. So atong pangitaon si shear of the moment. So we draw ato lang ni siya drawing kani siya nga diagram. On the left side we have reaction 1 and then on the right side we have reaction 2. Tapos mura siya nabahin katulo no. We have on this side, this is 5 kilonewton. And then diri we have an internal moment or internal couple which is equal to 2 kilonewton meter. So length ani is this is 1 meter. 1 meter sa tunga and then 1 meter sa to the right. Okay. So actually may taba is mura na tag mag-summation of forces. So para makuha na to ang reaction, para maka-draw ta og shear diagram and also the moment diagram. Let's say if I would like to sum moment at moment 2 at the second reaction is equal to 0. And that clockwise motion lugar, let's say it's positive. So we have R1, so 3 times reaction 1 minus the 5 kilonewton times 2 meters minus the 2 kilonewton meter is equal to 0. So natay 3R1 is equal to 12. Ato ding reaction 1 is just equal to 4 kilonewton. Reaction 1 is 4 kilonewton. So from this one, reaction 2 di is equal to 1 kilonewton. Okay, so now we can draw the shear and the moment diagram para atong magamit nato ang design of the beam. So atong shear diagram, this one. And then we also have the moment diagram. Okay. So for the shear, ato sa ning tungaon. Para dali ra tong pag-drawing. So diri musaka og 4 kilonewton. So we have a 4 kilonewton on this side. Tapos constant and then inaog siya 5 kilonewton. So we have negative 1 kilonewton diri taman sa second reaction, and then naipasaka nga 1 kilonewton. Now for our moment diagram, so area naman na siya dira. Atong area diri, we have length times width, or the base times height. So that is 1 meter times 4. So this is 4 kilonewton meter. This is positive moment. Here we have a negative moment. Atong area diri is 1 times negative 1. So this is negative 1. And then on this side, this is also negative 1. No? Okay, so let's graph. So ang first is that is 4. So from 0 degree to first degree nga line. So this is a 4, positive 4 kilonewton meter a moment. Minus 1 due to this moment. So munaog siya. That is 3 kilonewton. And then don't forget that we have a moment here that is negative 2. Sumudahan siya og 2. So mabili na lang is 1 kilonewton meter. Minus 1 moment because of this shear. So close 0. Ato ang moment diagram. Okay. So magamit na nato na natay V and M. So maximum nato nga shear is pila, that is 4 kilonewton. Maximum din nato nga kuan moment is 4 kilonewton meter. Okay. So masolve na nato si ang size. Okay. So take note, so kung natag-solve, take note that ato ang base is equal sa ni depth. So para nata unity sa itong design, ato lang himuon nga si base is equal to the depth. So let's start with the kuan flexural stress. So for flexural stress, we have F equals 6m over BD squared. Diba? And since CD is B naman because they are the same size, so may mo na siyang 6m over B cubed. So ato lang substitute no the values. We have the for the flexural stress, that is 8 megapascal or 8 newton per square millimeter is equal to 6 times moment na to is 4 kilonewton meter or 4,000 newton meter. And since naka-millimeter man ang uban unit, it is better to make the 1 meter into millimeter. So there are 1,000 millimeters per meter over B cube. Okay? So natin tayo B cube is equal to, ito na siya i-simplify. We have, sige ako lang isulatan Andre, we have 6 times 4,000 times 1,000 over 8, which is equal to 3 million. That is 3 million. So extracting to kuan the cube root, and then we can get the dimension or desired dimension for the beam. So itong minimum answer, we have 144.22 millimeters. So kang unit ani is naka cubic millimeter man eh. So in millimeter, or since this is the design, so ato na lang na ipasaka nga divisible by 5. So itong dimension, least smallest square beam is 145 millimeters. This is as per the flexural nga dimension or flexural nga consideration. Next, ato na pong i-consider is ang according to shear. Okay. So shear gani, that is for the square beam, that is 3V over 2BD. And then, atong B ug D is equal, that is, let's say that is B, so we have 2 over B squared. So substituting the values, we have 1.0 Newton per square millimeters. So again, ang Newton per square millimeters, that is megapascal, is equal to 3 times V. Ang V na to, that is 4,000 newtons. Okay, 4 kilonewton man to siya. Over 2B squared. So, natin tayo 2V squared is equal to, so nag-cross na siya, multiply. We have 2B squared is equal to 3 times 4,000 newton. Makansal ang newton. So, na tayo square millimeters na bilin. Over 1. So, pwede na nawala, no? Subtracting to square root, subtracting to square root. As per our shear nga limitation, ang ato arang allowable nga or smallest dimension of the beam is 109.5 millimeters. Or let's say approximately 110 millimeters. So which one ato ang gamiton? The 110 or 145 millimeters? So ang minimum requirement ni shear is just 110. This is the minimum requirement para niya. Pero for the bending, dili niya makaya ang 110. Dapat 145. So therefore, ato ang smallest nga square beam dimension should be the 145 millimeter by 145 millimeter nga beam. So this will be our answer for this sample problem number 3.